Hi everyone. Let's get started. Welcome to Building Camera Apps. My name is Praveen. I've been working on camera apps on iOS and Android for the past 1.5 to 2 years. And currently I work for a group video chat app called Houseparty. How many of you have heard or used Houseparty before? Oh, nice. The rest of you should definitely try it out with your friends. It's basically a group video chat app for up to 8 people, and when you open the app, you pretty much go live and your friends can jump in. How many of you have worked on camera apps? Oh wow, that's a lot. Cool. Well, today's talk is about building camera experiences for your app or building camera apps. So why build great camera experiences? It is becoming important as users increasingly rely on camera as an input. If you're using chat apps, you're sending pictures, videos, social media, social networking apps, like you are taking a lot of pictures and videos again. For note-taking apps, you are using OCR. So here are a few use cases before we get started. Firstly, games. Pokemon Go was a great example of how they used the camera to sort of build a game. And AR Core, which was recently announced. It'll be exciting to see new apps, new games built on AR Core. Then social apps, Houseparty, obviously, we rely on the camera a lot. Snapchat, Instagram. Utility, Evernote, again, uses it for OCR. Uber uses it if you want to add a credit card. You can just take a picture of your credit card. E-commerce, Amazon uses it to recognize products and just by taking a picture, or barcode scanning. Photo editing. If you look at device iterations over the past few years, phone manufacturers have been like spending a lot of time like refining your cameras and stuff, and like now there's like raw image capture across a lot of major manufacturers and such. So photo editing is again like a huge use case. So today, what are we going to talk about? What options are available to build camera experiences today? So the basis of the talk, we're going to talk about like different ways to implement camera experiences into your app today, the issues we might run into, pros and cons, and sort of run through very quick code examples for each way. And then at the end, we'll cover raw image capture, face detection, and stuff like that. So to get started, the first method, which I'm sure like you guys have used or tried before, intent. It's like any other way, like the way you do share intent and stuff like that. Primary use cases for this, if you're building chat apps or just uploading profile pictures into profile pictures, intent is probably your best bet. Then second is libraries. If you are sort of if you want to build the same experience in a custom experience into your app, this is probably a good way to go. Like if you're trying to build this QR code scanner, it's a step above the intent, or a basic photo editing app. If you want to take a picture and then like add filters and stuff like that later, libraries work pretty well. Then the third one is native APIs. If you're trying to build a hardcore photo editing app that takes uses raw capabilities, or if you're trying to build some app where camera is your core, such as Houseparty, you'd probably use native APIs. We're going to spend a lot of time on the native APIs, Camera 1 and Camera 2, because once you understand that, like using a library and debugging issues after that makes a lot more sense. So let's get started. So first, we're going to talk about the intent. We're going to do a quick, simple implementation, then go over pros and cons. And as I said before, intent is probably the most popular way. If you are adding a profile picture, or for your chat, if you're doing a basic communication app, this is the way to go. So to start, to create an intent, it's like any other thing, like share intent. You just do mediastore.action image capture. And then before you start the activity, make sure you check if there is there's an app that can handle the intent. A lot of times, like, people don't check this and it will lead to a crash. So you want to make sure that the user has some app that handles the intent for you. Then once that happens, it'll take them into whatever the user selected as their camera handler. And once they take a picture, it'll come back, and on activity result, you will be able to set that. You'll be able to set a preview image based on the intent result. If you want the full image, you have the option of passing in a URI when you create the intent, and on result, you can basically check the URI and upload the image or display the image. Same thing, if you want to do video, you literally have to change one line to capture a video, and it follows the same exact procedure. Basically, intent is pretty simple. It's just 2 steps. You fire an intent and you wait for the activity result. So the advantages. First, it's low risk, very few edge cases compared to the other 2 methods, because usually it goes to the manufacturer's native camera app or something, or any app where the user trusts. Then dev time, very quick to implement. It's literally a few lines of code, probably takes a few minutes to a few hours to implement. Then finally, you probably get great quality pictures and videos, because usually the thing that handles the intent is probably a really good camera app. Then the trade-offs. It's not very customizable. It will take you to whatever. It'll take you from your native app experience to someone else's app. So then very limited functionality. Like if you were trying to build something like Snapchat, where you have lenses and filters, it's not the best. It's probably not the way to go. User experience is not so great, obviously, because it takes you into another app and brings you back. So far I've covered intent. Like, it's very easy to implement, and it covers a few of the use cases. Next up is libraries. So primary use cases are for a library, or if you want to build a QR code scanner, or anything for like a basic photo editing app where you want to take a picture and provide the user with a good in-app experience, you would go with the library. And we have a couple of library options. We have Photo Apparat, Camera View, and Material Camera. Anyone want to guess like what Photo Apparat means? I actually just found out today. Yeah, it's camera. I've been messing with this for a while, and today was the first time I saw what it meant. We're going to run through a quick example using Photo Apparat. As we said, like, we want to sort of run through examples of each method. So it follows the basic builder pattern. You pass in a camera view that you drop into your XML. And then you can define scale type here. We want to fill the preview. Then photo size, you can define quality, one line. Then do you want to use the back camera or the front camera, which is the lens position? Then focus mode. We can pick whichever one is first available. It provides a really nice API. You can start with continuous focus, autofocus, or fixed. Then flash, first available again, same means the same thing. If it has red eye, pick red eye. If it has flash, pick flash. If it has torch, pick torch. And it's pretty safe. Like, if it doesn't have any of these features, it's not going to crash on you. And then just call build. Then just 2 lines of code. You need to handle on start and on stop. Later, when we cover the Camera 1 and Camera 2 APIs, you'll see exactly how nice this is, just to call like start and stop to handle LIFECYCLE. To take a picture, it's very simple. You call take picture, and then you can save it to file. And say you have a preview view where you want to display the image, you can pretty much just call You can listen to when the bitmap is ready and then set it to the image view. So what are the advantages of using libraries? This was just one example of a library, and I personally like it, but the other two are constantly maintained. So you can use either one of them. So the first, it's a great user experience because you can build it into your app. You can basically drop the XML anywhere you want with any dimensions. Next, minimal dev time for a custom experience compared to when you use native. It'll take you a lot more time. Then support from the open source community. As we know, like there is a lot of issues with Android and camera that is pretty hard. But the open source community is really good, and they usually get to, when a new device launches and something is not working, they are the first to respond. Trade-offs. So first, turnaround time to fix bugs. If there is a bug in the library for your particular use case, then you have to sort of wait for the library to update. You could fork it, but then like you might miss like some library updates. We've run into this issue at Houseparty where when the Pixel launched, we had an issue with the front. We were using a third-party library, and we had an issue with the front-facing camera. Longer time to debug issues. It's pretty similar to any library. Whenever you use a library, there's two layers of failure. You have to figure out, is it the library that's failing or the Camera 1 or Camera 2 APIs that are failing? And then potentially you probably can't build the best camera experience here because say the device manufacturer or the particular device, it doesn't expose certain features of the camera. The library can't do anything at that point. So like compared to the intent, whenever you're using the intent, usually it resorts to the inbuilt native camera, which probably has a lot more features. Next up, so to like sort of summarize libraries, it's very easy. You just build a camera, you start and stop it, and you can easily take pictures and videos. So next up is native APIs. So let's start by introducing them. I'm sure some of you have seen this image before. We're not going to cover this. So API layer, this is what we're going to focus on, Camera 1 and Camera 2. So Camera 1, as you all know, was the first API that Google released for camera. And for API level 21, and which is also Lollipop, they released Camera 2 API. So we pretty much need to implement both, and just because it doesn't manufacturers have to implement these properly. So sometimes, like even if it is API higher than 21, it doesn't guarantee that Camera 2 works well. So why do we need to also do Camera 1? This is a good graph. Firstly, like if you don't, you're going to miss out on 22% at minimum. But out of the 78%, if there is devices that don't handle the Camera 2 API properly, that implement the Camera 2 API properly, there's a chance that you're going to miss out on that. Next up, just also after Camera 2 is implemented, there's multiple levels, obviously. There's legacy, which basically means they have the features of Camera 1. There's limited, which means they have some features of Camera 2. Then there's full, which means most of the sensor controls are there. And then level 3 is for stuff like raw image editing. Camera 2 versus 1. What changed? So there's more capture methods and surfaces for Camera 2, control over exposure and raw sensor capture. And there's a new burst mode. It's also built from the ground up with a new hardware layer. And also Camera 1 is deprecated. So today we're going to cover, for this section, we're going to cover the Camera 2 API as it is more verbose and complex. So if you're able to understand this, you can definitely understand Camera 1. So to take a picture, these are basically all the steps that we need to go through. One, we need to set up a view to stream. Then we need what I mean by a view to stream is whenever you're pointing to an object, you want to see that on your camera. You're not going to blindly take a picture. So it's basically showing you the image frames. Then get a camera device, then configure the surfaces to what the camera device can do. Then we need to get the camera object, then create the actual stream, and finally you can take a picture. So before that, obviously we need to handle permissions. It basically needs the camera permission, write external storage, very basic. And if you're doing video, you need to do record audio as well. Then features manifests. If you've built like any app, like I'm sure you use the internet permission and stuff like that, those don't usually need features permission. But when you're using the camera, features manifest is like pretty important. So you want to define Android.hardware camera any so that Google Play will filter out any devices that don't have a camera. Otherwise, your app is gonna just crash anytime you need the camera. Next, for video, you pretty much need the microphone. Then for the camera, you can also do it by sub-features. Like if you need autofocus, if you're trying to build a selfie app, you probably want the front camera. So like you want to define that so that Google Play will take out any devices that don't have a front camera. And then you can always, if there's a feature that you really need for the app, but it's not required, you can always define it as required false. So now let's actually start by setting up a view to stream. So we have two options here. We have a surface view and a texture view to sort of stream. First, the differences between the two, you can't animate, transform, or scale when you use a surface view. The second thing is you can't overlay two surface views. But the texture view also has trade-off. It does consume more memory than a surface view. So if you don't need any of the above features, you can use a surface view. For today's demo, we're going to start with a texture view. So you can just drop in the XML, and then to create the view, basically to stream, we're going to set a surface texture listener, and we want to wait till it is ready before we proceed to the next step. So once you set up the view, now you're ready to now you're ready to basically create a camera device. So to do that, there is the Camera Manager class. It allows you to get available cameras. By cameras, I mean like front camera, rear camera, or external camera. And then it gives you the characteristics of each camera. And also, finally, it'll let you open the camera. Camera characteristics, again, simple terms. Basically, it's properties that describe the camera. And camera metadata is just a key value class that has all these constants for camera characteristics that you can query /set for requests and for capture requests and capture results as well. So let's start with getting a camera device. Very simple. You use the system service, get the camera manager, and then get the camera ID list. Usually it returns something like camera facing back and camera facing front, or external if there is one. Next thing, we want to see what this camera can output, and then configure our surfaces to that. So in order to do that, we have multiple surface options. We have the surface view, surface texture, the two we talked about, image reader and media recorder. Image reader for taking pictures, media recorder for taking videos. There's also render script allocation and media codec, which we probably won't cover today. So image reader. It allows access to image data rendered on a surface, and you can use it to acquire the latest image, next image, and so on. Then it also returns like image characteristics. Media recorder, very simple. It's very similar to the image reader used to record audio and video. And you can set properties like frame rate, bit rate, duration, and such, like max duration. Then next thing we want to do is configure surfaces. So say we pick the back camera here. We want to get the camera characteristics, and out of the camera characteristics, we want to get the stream configuration. And once we have that, we want to see what are all the output sizes of this stream configuration for a JPEG. So once we have that, we can now create an image reader with the JPEG, with one of the preferable like JPEG width and height. And then you set an on image like available listener. So inside, once you get the image reader, you can always use it to get latest image or get the next image, and so on. And it usually returns you the image frames. So once that's ready, you want to get the surface for the image reader for the next step. So next, we want to get a camera object. So when we get a camera object, it's basically a camera device. It's a single camera connected to your device, your Android phone. You can use it to create the capture session and create a capture request, basically. So getting a camera object, pretty straightforward. You just call open camera on the camera, if it's front camera or rear camera or external camera. And then you want to save the reference in order to use it in the next steps to create a stream or take a picture or handle LIFECYCLE methods. So creating a stream. So far we have configured our surfaces to these right dimensions, and we've created the camera object, but we still haven't started streaming what the user is pointing to yet. So that's what this step is for. For that, we're gonna first need a camera capture session. It's basically used for capturing images, reprocessing images, and you also need to pass in a list of surfaces. So as we can see here, we've created a JPEG image reader, a JPEG surface, and a preview surface. So we're basically going to create a capture session, passing in these surfaces. And once the capture session is ready, we want to go to the next section. So if a lot of cameras nowadays have like the double tap to flip, when they flip it, you want to go through these steps again. With say if it's if from back to front to back, you want to make sure you handle all these steps again. Then creating a stream. So now that you have a session, the next thing you want to do is start streaming into the preview view. So for that, you basically create a capture request, add preview surface, and here you can add a bunch of features, like you can add like balances, white balance, and so on. So once your capture request is ready, you want to do session.set repeating request, and that will start your stream into the surface. So now that the user is able to see the stream, whenever they press a button, you want to take a picture. For this step, you basically want to create a capture request again, and you want to add the image, the surface you got from the image reader, and then you can again set the same. You can set options here again, and once that's ready, you want to call capture. When you call capture, keep in mind that your request and result are not always the same thing. Sometimes you might pass in some like feature options that you want in your request, but when the camera takes the capture, it might not have the results. So like in case you really need some feature, you want to sort of go back and fix it if the result turns out to be not what you expected from the request. So to summarize, we basically created a surface texture view. Then we got a camera device, the rear camera. Then we configured the surfaces to the camera's width and height. Then we got the camera object, created a stream, and then took a picture. So this is basically all the steps you need to follow in order to take a picture using the Camera 2 API. And Camera 1 is a little bit shorter. Next, we want to sort of talk about like more advanced features like raw image capture. How many of you know what raw images are? Okay. Basically, what we got before are JPEGs. They're bright, sharper, and they're all processed. What raw images are basically they're raw like camera sensor data and a lot more editable. So it's a very similar process. Instead of image format.jpg, you just pass in raw sensor. And then you follow the same thing. Once the surface is ready, you want to grab the surface. And when you create a camera capture session, you want to pass in the surface again. And one thing you have to do for this is make sure you pass in, when you do the request, you want to pass in lens shaping map mode and map mode on. And then also Android provides us with a util class. DNG stands for Adobe's raw format and the way Android stores them. So now that we have the raw image, all it takes to create this class is the camera characteristics and the capture result. Also keep in mind that the raw images are like really big. So this is a basic util to sort of write to file, and you can set a bunch of properties on the creator. You can set orientation and stuff like that, and other sensor info. Next, now that we sort of know how to do raw images, next we want to do filters. By far, my favorite way to add filters is GPU image. It provides us with like a super simple API, and they are GPU accelerated filters as the name suggests. So in order to do that, you basically get a URI and set it onto the GL surface view. So GL surface view is basically an implementation of the surface view that uses like a dedicated surface for displaying OpenGL rendering. So once the image is set, you can GPU image also comes with a bunch of filters. You can just set, I guess I set a saturation filter here, and then you can call save to pictures. Next up, if you want to do face detection, we talked about creating a capture request. In the capture request, you just basically pass in like face detect mode and face detect mode full. And then in the result, if that feature passed through, you want to check if it has faces, if the mode was there, and also if the faces basically showed up. If you use Photo Parrot, they have like a good complementary library called Face Detector, which you can pretty much use, and it handles a lot of stuff. So these are sort of like very high level overviews of some of the advanced features that Camera 2 API can do. Face detection is also available on Camera 1. So the next thing is, when we build camera experiences, what are stuff that we often overlook? Handling orientation changes. We think that the surfaces basically would handle when you rotate your phone and stuff like that, but there's a lot of issues there. if you've ever taken a picture and you went to a photo viewer and it's like rotated, it's probably because they didn't do this properly. So you always want to handle for that. And always keep in mind that the front camera versus rear camera is always the inverse. Then handling life cycle. Whenever you put the app in the or the activity in the background, you want to make sure you close the session, the camera, the image reader, the media, whatever. And then when you come back, you want to start these again. If you have the texture view, then start with it. Otherwise, like start at the next step. It's basically the 6-7 steps that we did. You want to start at the beginning again. And then, so as we've seen, it's not too hard to sort of implement Camera 2 API or Camera 1 API, but the more complicated part is the inconsistencies across devices and APIs. So before you build any features, you want to always keep checking like the hardware implementation levels before you start using features on a certain device and stuff. Then whenever like Camera 2 starts, like Camera 2 gives you a dark camera or something, always like try like Camera 1 or any other issues that you see. Try to run Camera 1 on there and see if the device responds properly. Next thing, server config to toggle features. So one popular way I've heard is passing up the device's model and API level, and say some feature starts crashing on some device, you can basically tell the server, hey, like turn off this feature. So you want to build the Camera 1 and 2 APIs in like a very configurable way where you can turn off features or like flip between Camera 2 and Camera 1 based on what the server tells you. So what are the advantages of using Camera 1? It's highly customizable. It's the closest you're going to get to the hardware, so you can probably build the most here. It's a great user experience when built right. And finally, it's like faster learning cycles and easier to resolve issues. You know, you're basically at the core. So it's easier to sort of say, you don't have two layers of failure now. You can just say, oh, I think Camera 2 is failing. Let me try Camera 1. If Camera 1 is failing, let me try Camera 2, and so on. Next up, trade-offs. So scope of failure is high because you're wrapping two camera APIs, and you're also making them very configurable. So it's much higher than sort of firing an intent or using a library which has a lot of open source support. It requires a lot of dev resources, obviously because you are wrapping like two APIs again. Also, it could potentially lack the support to build the best camera app if the manufacturer doesn't expose certain features. So to conclude, one, we talked about the intent, which is really easy to implement, but pretty hard to like configure, customize and stuff. Then we talked about libraries, which are sort of medium time, like it's still easy to implement for a custom experience. And finally, native APIs, which take a lot of dev resources, but you can customize the best here. And that's it. Thanks for your time. I'm Chekuri on Twitter. And if you want to talk about, if you have questions or anything, I'll be around for the rest of the day. And you can always reach out to me on Twitter. Thank you.